about 3 years ago, we wanted to find a 3D tool that could help us visualize some of the changes that were coming to a particular area of production. So we used the Unreal Engine to flesh it out very quickly and try to get consensus across the different shifts about what that change was going to look like. Now, it turned out to be very popular. People liked it quite a lot. So I was asked to get involved in some bigger projects. Fortunately, at the time, we were integrating the Electric Mini into production. So there were a lot of changes, particularly in our engine line, where a lot of new material needed to be incorporated because there's not a lot that goes onto an electric engine. So we built some custom tools inside of Unreal just to help us make things like racks. And racks really are the bread and butter of the production line because we need to have the material organized in such a way that it's easily accessible to the associates when they're building the car. Line side space is quite crucial, and being able to try and find the most optimal way to organize that is really key to producing a quality car. Here you can actually see just the amount of stuff that needed to be incorporated, and it really was a good tool to help create conversations around possible solutions. And what you see here is actually the work of people who have not actually come from a gaming or 3D background. We use point cloud scans, which we can import into the engine to actually ensure that our measurements are correct, and then we can have confidence in the area that we're working. And of course, since it's so easy to set up VR, we're able to get associates into a simulation and show them some of the changes that they're going to see, and get any sort of feedback as to what they think about this. So then what we wanted to do is we wanted to push things a little bit further. I wanted to actually see the car being built. So what we did is we got the build order, and what you can see is the dress level of the car as it goes through production. So you can see the correct order of the fitment of every part, every washer, every bolt in the correct part of the factory. And we drive these simulations using blueprints, which are incredibly easy to use. And because of that, we can hand this sort of thing over to people from production. So again, people who don't have a background in 3D tools, who've never coded anything in their lives, they're actually able to take what we initially build for them, and they can tweak it. And it's a very non-destructive workflow. And that was the key thing. Yes, we can do it. And yes, it has its benefits, but really, if we can't make it easy enough that that people can actually utilize it, then it really is worthless. The saying in our department is we have to be lean before digital. And so I went about trying to get a really easy to use method for creating these simulations. And this right here, this is not my work. This is the work of an intern called David Oriaki, who I said, he was my guinea pig. I said, take this method and see if you can simulate the build, the subassembly of the cockpit. And then we needed to move on to how does the parts actually get delivered to the line side. And so we started to work with logistics on a couple of things. Logistics had some things that they wanted to look at, specifically the traffic flow of the tow trains. So what we have is this simulation here being driven by the actual data that logistics have captured. So on any given day, we have a record of when a tow train left, what it was carrying, what the parts were, what the quantity was, and where it stopped to deliver those parts. So what you can do is you can go back a day, a month, a year, and you can actually recreate the exact path of each tow train on any given day. Then what you can do is you can actually tweak some variables with that. And if you were to try and say, change the amount of, change the frequency that the tow trains left. And it's proved quite interesting results. And now our plant in Mexico has started to adopt this to try and see if they can't use it to fix some of their traffic flow issues. And then container planning from logistics approached me, and I didn't know what container planning was. It turns out it's a department responsible for planning containers. And one of the things that they asked is if Unreal could be used to do concepts for containers. And I said, look, I don't know, it's not a modeling tool, but you could certainly do some kit bashing. And so I gave them this demonstration where I just squeezed a cube a couple of times, and they went nuts for it. Apparently this was something that they really liked, because one of the tools available to them is CATIA, but a lot of people really do struggle with CATIA. So having a quick and easy tool where they could create concepts was it was quite elating for them. So now, now I don't know a lot about logistics topics, and I refuse to learn. So instead, what I do is I find people interested in using this software to try and visualize things, and people from years of background in this in their industry, and I just give them the means to simulate certain things, and they've done some fantastic stuff. This is the work of Emily Strachan. She's one of the our colleagues in logistics. And she's done an enormous amount of things. She simulated whole warehouses so that they can keep a track of where things are, you know, processes that forklifts go through so that you can optimize them, traffic flows both inside and outside of assembly, stuff that goes completely over my head, but she's done a great job. And again, there's a lot of people that are utilizing it that don't come from a background of using 3D tools, certainly not any coders. And that was what was key for me, is if we could get people from a production background, people with years of experience in their set discipline, and we could give them a tool where you don't need some sort of in-between person to bridge the gap between the technology and the person who actually knows the processes, then we should be on to a winner. And you can see here, again, all of the stuff you're seeing on screen is actually the work of non-developers. And it's quite crazy to see how quickly people can get up and running with a tool and utilizing blueprints to do some really complex things. Yeah. So it's been a really exciting journey, and I've had the opportunity to meet a lot of people from a lot of different departments and work with them on their topics. This one here was quite interesting. We've got quite a big collaborative robotics interest inside of assembly, and some of the concepts that we use for these robots are a little bit out there. So using Unreal, what they can do is that they can quickly mock up these concepts and use the rotation of these to kind of use in the beginning of a simulation, of an actual simulation. And also trying to convey what you're trying to do to management so that you can get buy-off can be a little bit tricky sometimes. So using this, it's a very quick and easy method to get that. This was another interesting use case. What we had here was the need to create a camera cell. We have vision systems in certain parts of production that are checking a few different things. Some of the things are checking to see that a part is fitted correctly, whether a part is fitted at all. Some other stations are actually just checking throughout production to see if any damage has occurred on the car. This way, if we do see any damage, back to an approximate source of where that damage may have occurred, so that we can start to tweak the processes to ensure that it doesn't happen again. And what's interesting is now they're starting to use this to create images to help train artificial intelligence inside of vision systems, so that they can more easily see what is a good car and what is a faulty car. So the facilities that drive the car through production, the machines that build the machines, as someone once put it, these are of enormous interest to me, and it's what actually got me my current job inside of Germany, where I was put into the virtual commissioning department. Now, virtual commissioning is the act by which we test future facilities digitally to ensure that they are properly coded to actually carry out the task. Now, you don't always need a 3D simulation of these facilities, but it does actually help in a lot of cases. And it's my focus now to ensure that we get as accurate as possible a geometric simulation of what's actually going on inside of production. So another aspect of this, it's not just the facilities, but it is all the components behind that are driving these things. What you have is a PLC, which is the brain of a facility. And from the PLC spreads out a whole network of sensors. These sensors are looking into every aspect of production to ensure that everything is going according to plan and as expected. And if something unexpected does happen, these signals go back to the PLC to explain what's happened, and then the PLC gets to make decisions from this. Now, it's not a simple case of this sensor speaks directly to the PLC. It must go through a lot of Profinet devices on its journey back to the PLC, which alters the information. Without getting too technical, there is just an enormous amount of data to have to deal with here. And what we want to do is make those connections, have the accurate 3D representation of where these sensors are, so that we can drive the digital inputs and outputs inside the 3D simulation, feeding that information back to the PLC so that it can make decisions, and then we can see exactly whether or not it's been coded properly. And it's a Herculean task, but we are working with some of our suppliers on this to actually create something that we can all benefit from. And one of the things you can see here, just on the right, there are every object has a source and a target, and very quickly we can go from any sensor to each of its sources, to the Profinet device, to the scalins, all the way back to the PLC. Therefore, and this just demystifies and makes it a lot easier to actually see, to focus on the bits that you want to try and troubleshoot. So here again, you can see some of the actual correct movement of these facilities and how we actually we're getting these sensors placed so that we can feed back the information to the PLC. And although we're very far from rolling this out, we only started, I only began in November on this topic, but already there's been a lot of interest from a lot of different partners, and we're making a lot of progress. But here is just a little example of the multi-user feature inside of Unreal. And for me, the greatest thing about a tool like this is that I can get together in a single simulation with colleagues from across the globe, and we can have that collective knowledge in one place where we can discuss and troubleshoot problems. And that for me is priceless.